Okay, so hi guys, in this video we're going to be practicing our knowledge of indefinite integrals and how to evaluate them by doing a few practice questions. So if you want, pause the video before attempting this question, then I'll pause the video before watching me attempt this question. So, okay, let's get started now, assuming that you finish the question. So let's evaluate 6x to the power of 5 minus 18x squared plus 7 dx. So the important thing we have to do first is realize that all of these parts use the power rule. So what do we do when we have the power rule? Well, we increase this power by 1 firstly, making it 6, and then divide it by the coefficient over here. So 6 divided by 6 is just 1. That's nice, which gives us x to the power of 6 for the first part of this integral. And then for the next part, we do the exact same thing. Increase the power by 1, that becomes 3. And then 18 divided by 3 becomes 6. So it's, well, not plus, minus 6x cubed. And remember that it works the same way in which the powers are done, like it works the same way as in differentiation, because the powers are done separately when you have a minus sign. If it's a multiplication sign, it's a lot different. But you don't really need to know that for GCSE level. Then with 7, obviously the power of x is 0. So you increase that by 1, which gives us 1. And then 7 over 1 is just 7. So it just becomes 7x. And then, of course, we have to remember to add the plus c. Because any constant could be present when you're differentiating like this thing. When you're differentiating this thing. And the constant will immediately go away. So we don't actually know if there's anything else. So that's our first answer. Okay, so let's move on to the second set of problems. So the question asks us to integrate each of the following functions. So let's start with this one. Okay, so the function we have to integrate is 2 cos 2x minus 5 dx. All right, so the first thing we have to realize is that this over here gets divided rather than multiplied by here. So we take the integral of, sorry, not the integral, the differential or derivative rather of this part, and then we divide it by the coefficient of cos. So the derivative of 2x minus 5 will give us 2. Then we divide 2 by 2, which gives us 1. So that just becomes 1. And then we realize that cos becomes sine when integrated. So it becomes sine. And then obviously the bracket doesn't change, because if you think about the derivative, let's say we had the derivative of this, right? We would just be multiplying what's in here by the coefficient. But we wouldn't actually change the bracket. It's a bit like e to the power of x in that respect. So it just remains 2x minus 5. And obviously you don't want to write the 1 like that. We'll just eliminate the 1 because it's the same as this. So that's the answer for this one. And then let's go to this one now. So we have to integrate negative 2 sine 2x plus 5 dx. So first thing we have to do is differentiate this part. That just gives us 2 again. And then negative 2 divided by 2 is negative 1. Then we have sine. Sine becomes negative cos when being integrated. So we have, let me just write this in brackets, negative cos. And then obviously the bracket remains unchanged, so it becomes 2x plus 5. And, oh, I forgot to mention, we should always add plus c here. So over here, I'm going to add plus c. Now negative 1 times negative 1 just becomes 1. So we have cos 2x plus 5 plus c as our final answer. Finally, let's go to the last one. So we have to integrate 2 cos x minus 5. So this becomes dx, sorry. So we have to, x minus 5 differentiated is just 1. So 2 over 1 is still 2. So we have 2. And then cos differentiated becomes sine. So 2 sine x minus 5 plus c is our answer for this one. Let's look at one more example before we wrap up this video. Okay, so let's take a look at this last problem where we have to match each definite integral to its result. So in this question, you might be tempted to just integrate these functions. But as we've learned, differentiating is a lot easier. So why don't we just differentiate the result and see if it gives us one of these integrals. So let's take ln 4x minus 8. That becomes 4 over 4x minus 8, right? Because you have to put the differentiated part on top and the undifferentiated part at the bottom. That becomes 4 over 4 times x minus 2. These cancel out to give us 1 over x minus 2. So, obviously, this is a pairing. Now let's do that for the next one. So we have ln 4x to the power 4 minus 8. And we have to find the differential. So 4x to the power 4 minus 8 differentiated gives you 16x cubed minus, oh no, not minus anything because it's just differentiating. So 16x cubed. You're dividing it by 4x to the power 4 minus 8. If you factor out the 2, you get 8x cubed over 2 times 2x to the power 4 minus 4. Cancel this out. 8x cubed over 2x to the power 4 minus 4. But wait, you can factor out the 2 as well. So you get 4x cubed over x to the power 4 minus 2. And that matches up perfectly with this one. The reason you wouldn't want to integrate for this kind of question is because, okay, so let's take this one, right? 1 over x differentiated, we know is just ln x, like that. But that looks nothing like what it's meant to, which is over here, ln 4x. Ln 4x and ln x are not the same thing. But we can tell based on the other questions as due to simplification that this works. So you wouldn't actually be able to directly prove it like that. Okay, so let's take our last example, ln 4x. So derivative of 4 is 4. 4x is 4. And you divide that by the undifferentiated one, which is 4x, which cancels out to give 1 over x. So you see here that this is not the same as ln absolute value of x. But because we canceled out everything, it still led us with the same integral. So that's why this one over here is matched up with this one, and we solved it. So this one wasn't precisely an integral question, but it had integrals in it. And it's important to recognize when you need to integrate and when you don't need to. So that's it for this video. You don't really need to know many differentiating rules. I've kind of covered them all in the last video, but here's just some practice that we did just to get the hang of it. Thanks so much for watching, and we'll see you in the next one where we'll cover some of the applications of differential calculus.